Hello, this is Susan Poss at Spartanburg Community College. This is the last video on section 5.3, and this one is dealing with how to evaluate polynomials. And evaluate usually means taking a number and plugging it in. So I wanted to call your attention to the notation here. We've got function notation, p of x. P of x is how you read that. The name of the function is p. And this value that sits inside the parentheses is called the argument. And generally you'll see that whatever's inside the parentheses, the letters over on the other side will match that. You'll talk more about this when you start to talk about function notation. And here you can see that we are asked to find p of 3. So now it's not an x anymore, it's a specific value. So I've made a couple of notes out here. When we look at the right side of this polynomial function, we can see that it's got 3 terms, so it's a trinomial of degree 2. 1, 2, 3 terms. Highest degree is 2. X is the argument. So the next line will look like this. Instead of p of x, I'll write p of 3. And I'll come over here onto the right-hand side and do the replacement. Let me change that color there. So the argument 3, goes into the right side, replacing the letter, the variable. Now we do the math. So you remember your order of operations. You have to do this squaring first. And the next time through, of course, you can skip some of these steps. I will do the multiplication. And finally, I'll do the addition and subtraction. So p of 3 equals 36. What does that mean? That means that if we graphed this p of x, we would have an x-coordinate of 3 and a y-coordinate of 36. So again, it's just understanding the notation and then doing the work. Let me scroll down just a little bit. On this next one, you'll notice it says p of y, and this is a lowercase p, so this lowercase p is the name of the function, and this y inside the parentheses is the argument. And one other thing I want to call your attention to is that the letter in the argument position matches the letter that you see over on the right-hand side. All right, so just looking at the right-hand side for a minute, it's a polynomial. I see 4 terms over there, and the highest degree that I see is 3. So this is a polynomial of degree 3. And now I'm asked to find p of negative 2. So here we go. You see I've written down the lowercase p for the name of the function, and then in the parentheses for the argument, I've put the negative 2, and you'll see me making all those replacements over there on the right-hand side. All right, so here I go with the math. Remember to do the raising to the powers first. And I'll hold off on this multiplication for a minute. And finally, I'll do the addition and subtraction at the end. What is that, 18 positive? So that brings me down to, I think, 22 negative. Yes. So that means, let's get the notation in here. Lowercase p of negative 2 equals negative 22. And again, if we were graphing this polynomial function, we would call it a cubic function, and one of the points on that would have an x-coordinate of negative 2 and a y-coordinate of negative 22. I know that's confusing because this function is written for you in terms of y, Maybe I shouldn't have said that, but I do want you to get accustomed to that notation and what it means. All right, so those were the easy ones. Let's try some that are a little more challenging here. So we've got a function here. Here it is. It's called f of x equals negative 6 minus 1. And the argument that we're being asked to put in here is a minus 7. So remember, the argument goes in to the function and replaces the letter x with whatever x in this case, it doesn't always have to be an x, replaces this letter x with the argument a minus 7. So you see that's what I've done there on that second line. I've removed the letter x and replaced it here with the a minus 7. And on this one, that's the best I can do, is just to tell you that when I took this function f and I plugged in with an a minus 7 argument, this is what I got, negative 6a plus 41. And the last one, we have another f of x equals negative 3x minus 14, and the argument this time is 2a minus 1. So again, you'll see that I've taken the function, I've written down this coefficient, numerical coefficient, negative 3. I've left this opening here where I've put in the argument 2a minus 1, and then I've just copied down the minus 14. So now I'm doing the math. So when I take function f and I plug in with an argument of 2a minus 1, I get negative 6a minus 11.